more than once this semester, but I'll do it again. Director of the Wallace Stegner Center for Land Resources and the Environment here at the S.J. Quinney College of Law. We're very pleased to have you with us today, and we hope that you'll find time to join us on some of our other upcoming events. I should note that our website has information about the programs that we'll be hosting next semester. I did want to highlight our 24th Annual Symposium on March 21st, 22nd. The topic this year is Recreation Challenges on Public Lands, derived from our Public Lands Conference last year, and will feature as our keynote speaker former Secretary of the Interior Sally Jewell. Other quick announcements, we'll be passing around a sign-up sheet. It helps us to track attendance and to alert people to our events. Please sign up and we'll get you on the, I guess it's the email list these days. King's English Bookshop has copies of our speaker's book outside, and he'd be happy to sign them after today's presentation. Off with the cell phones, and during the question and answer period, please try to use the microphone so everyone can hear the questions. I'd like to particularly thank the Cultural Vision Fund that's provided funding for this lecture, as well as other Stegner Center events, including our symposium, our Young Scholar program, and several of our other programs. They provide broad support for the Stegner Center. Also today, I'm very pleased to extend thanks to the Nature Conservancy of Utah, which has helped and joined us to sponsor our speaker. The topic today, as you all know, is Energy Sprawl Solutions, Balancing Global Development and Conservation. It derives from the book that our speaker, Joseph Kiesecker, wrote. Joseph is the lead scientist for Nature Conservancy's Conservation Lands team. His main responsibilities include developing new tools, methods, and techniques to improve conservation. He's pioneered the Conservancy's development by design strategy that improves impact mitigation through the incorporation of predictive modeling to identify solutions that benefit conservation goals and development. He also conducts his own research, and his areas of research interest extend from disease ecology to the effectiveness of new conservation tools such as conservation easements. He's widely established in this area, and we're very pleased to have him with us. Please join me in welcoming Dr. Joseph Kiesecker.
Thank you. So it's great to be here. Utah had a profound influence on me as a little kid. My dad taught high school in New York City, and not every summer, but a good number of summers, he'd take us out of the city and we'd spend the summer in the Pacific Northwest or the desert Southwest. And so it really opened my eyes. And I remember a trip when I was only in the 3rd grade where we spent most of our time in Colorado, Utah, and Wyoming. And for somebody who grew up in what I call now Little Sky Country in Brooklyn, New York, to see these open vistas was pretty amazing. I think it set me on the path of where I am today in terms of working for a conservation organization. I took a sort of really strange route to get to where I am right now. So I started out on the sort of traditional track when you go through grad school. You know, your end goal, at least for where I sat, was to get a postdoc and then to get a faculty position. And that's what I did. So did a postdoc after I got my PhD, and right after that took a faculty position at Penn State. And my work was primarily on disease ecology. So, when I came to the Nature Conservancy, it wasn't like I was an energy expert and sort of stepped right into a field that I knew. But I started out working in Wyoming, and the 800-pound gorilla in the room, as you probably know if you've been through Wyoming, is energy development. It's oil and gas, and it's wind. And so, it forced us to focus on that. And surprisingly, a lot of the modeling you do in disease ecology, which is very spatial in nature, how hosts come together and hosts and pathogens move to contact one another, is really similar to thinking about spatial planning for energy development. So over the years, at least initially, I've learned more about energy, a variety of different kinds of energy than I had cared to. But now it's part of the core of what I do, and it's an exciting field to be working in. When I started, I would definitely say the goal and a focus of our work, we originally called it energy by design because we were only focused on energy footprints. And then we moved to sort of look more broadly at the other kinds of development footprints, agriculture, residential subdivision, a myriad of pretty much anything that drives land use change that you can sort of look out and forecast forward, was really a defensive strategy, which was trying to protect land, identify those places that we cared about, and then try to keep development out of those areas. As I got more interested in the energy footprint and the growing energy footprint, started to realize that climate and energy obviously are very intertwined. So this is a great graphic. It's actually it's not mine. I wish I could claim that it was mine, but it's WRI's. So it really looks at just each country's piece of the overall global emissions. And within each country, you can sort of break it out to what the sources of emissions are. So the quick take home is the top 10 emitters are responsible for about 70% of the emissions. Not what I'm going to talk about, but if you look within any of those countries, energy is the largest piece of the pie. And so if we're going to address emissions, and we're going to address climate change, we're not going to do it unless we radically overhaul our energy systems. That's the reality. So what we started to do then was think about ways that we could play more of an offensive strategy on renewable energy. How can we promote renewable energy and try to help renewable energy move along without alleviating some of the hurdles that it has to go through on the environmental side. So these issues get even bigger and more in our face when we start to look at what the future looks like. So these are just projections of a growth increase by 2050, both in terms of GDP and population. We're going to put a lot more people on the planet. And a lot of those people are going to be wealthier. So they're going to use more resources. That means we're going to need to have more food, more energy, and more water. Some colleagues and I tried to look at what that footprint looks like into the future by projecting areas that are likely to have development from pretty much the major sources of land use change, from energy, urban expansion, agriculture, and sort of put those the high potential areas on the ground and map them. And that's what's here on the map. The sort of dark red areas are places with high potential for conversion from the sum total of all of those future footprints. We can look at what it looks like. So the top category there is just, again, those development threats. And then you overlay that with natural lands. What's still in a native vegetative state, and where do those intersect? We're looking about 20% of remaining natural lands that are at risk of being converted. And if you look within those, only about 5% of those are protected. And I have to say that protection doesn't always protect the way that we would like for it to, especially in a lot of developing countries where protected status is pretty fungible, and even a national park can have a lot of development within it. So we can put a little bit of finer point on that. This is actually from a paper that the Nature Conservancy just put out, led by Heather Tallis, that I was involved with. It looks at a set of scenarios. One is sort of a business as usual, and the other is a set of different sustainability options. With the comparison, we didn't try to change those growth projections. So we didn't say we're going to have fewer people on the planet, they're going to have lower GDP, or they're going to consume resources less. We just said, well, what if you try to influence where and how those things happen? The one I wanted to highlight on was some of the land footprints around, in particular around energy. So for the most part, everything in this story on this graph is really positive. So the agricultural footprint can shrink. That's if we really push for sustainable intensification. We also maybe do some movement of crop productions around the world so that crops are grown where they're more biophysically suitable, so the yields are higher. It's a biophysical potential. I don't think, there's no global control room that says we're going to grow crops here, we're going to move them over there, right? But the goal was to say, could we come together to make that happen? We look at natural areas. Those would expand compared to the business as usual. Protected areas would expand, partially because we said we're going to meet our ACHI target goals. The only one that's really interesting is the energy footprint. And so where we actually try to move to more sustainable energy production, the land footprint gets a lot bigger. So that's primarily, so this is an EIA projection. It's one of the myriad of scenarios they have at look at energy futures. Looks at our current mix of energy, 2012, it's a little bit different right now. The renewables have already grown from 2012 to 2018, but projects into the future that renewables will be about 51% of our electricity generation. And that creates the challenge primarily because of the land use intensity associated with different kinds of energy. So if we look, the summary of this is that things that are really good at their spatial footprint, like coal and natural gas, because they're really concentrated forms of energy, emit a lot of CO2. And things that are low on the CO2 side tend to have a bigger footprint. So they're going to create a challenge that we're going to have to deal with. So right away, I know people might be saying, okay, well, global climate change is a big issue. Should we be concerned with a little bit of habitat loss, a little bit of conversion? So if we look at this in the big picture, this is actually from a study that we have in review right now that took all of the NDCs, the nationally determined contributions that countries put forward as part of the Paris Climate Accord. And most of those are just summarized in terms of emission and reduction targets. So they say, we're going to reduce this amount of CO2. Some of them go back in time and say we're going to go back to 1990 emission levels, and others are more complicated. The take home is, though, that they put out an emission reduction target and often don't say exactly how they're going to do it. So with this analysis, we figured out a way to translate those emission reduction targets into actionable renewable energy goals. And so if we look at these three smokestacks, that's supposed to represent the emissions. First of all, when we add up all of the emission reduction targets, it's about 17.7 gigatons of carbon. We already know there's already been a bunch of analyses that that's not enough to get us to 2 degrees or considerably less than 2 degrees, right? But there's still, those commitments are made, so let's roll with those, and I'd be happy if we got if we got there. And when we did this translation of those emission reduction goals country by country, looked at how much electricity they currently generate and the sources of that electricity, which is largely fossil fuels, translate that, shunt that into renewables, we basically end up with about 6 gigatons of carbon that we can get by ramping up renewable energy to just take out the amount of electricity and heat generation that we have within those countries. Then we asked, okay, great. That's about 34-35% of the total goal. You can go even farther, I think, if you switch transportation and other sectors, but we wanted to just keep it relatively simple. We asked, okay, what if that proceeds in a manner that doesn't think about land cover and really just maximizes exploitation of the resource? What happens? Well, when that energy goes on the ground, it clears natural land that releases carbon. It releases about 1.5 gigatons of carbon. That's almost 10% of the total Paris Climate Accord commitment. So if you don't care about the biodiversity loss, we need to be thinking about that carbon loss, so that means we're going to need to put in that much more renewable energy to deal with that emission loss. Not a gloom and doom story. We also looked in a comparison analysis at how much land that is low conflict, not important for, or less important for biodiversity, probably doesn't have the high carbon values. And the answer was there's about 19 times of land that we need to meet that goal. So that land, when I say land, it's not just land, it's rooftops, it's existing hydropower doesn't have hydropower turbines in it, it's agricultural fields, it's mine sites. So there's a lot of land. We've been pretty good at converting land around the planet, so there's a lot of space to do this. And this just shows the top 10 emitters. The inside of that pie chart is the amount of converted land they have that is economically viable, wind, solar, or existing hydropower. And then the outside is just a comparison of how much they actually need for their NDC target. So a lot of space, a lot of ways to figure out how to do it. So really super positive. But how are we going to make that happen? So now I'm going to pick on a little bit of the way that we plan for development. So this is the typical way that a development project happens. Someone proposes a wind farm or an oil and gas field or a mine site, and there's an environmental impact assessment process for that individual development. It has a potential impact. We can look at ways to avoid some of that impact, so we can say, all right, don't develop some portion of that because there's some important resource there. We can also make recommendations about how to minimize that impact, maybe design the road network in a way that goes around something, or traffic patterns or activity, a myriad of different things. Once some of the impacts happen, we can restore some of those things on site. At the end of the day, even the best development leaves a residual impact. And so we can think about ways to use things like biodiversity offsets. So those are conservation investments or investments that are made away from the development where it happened to sort of compensate for that loss. We do some restoration, or we protect something that's at threat of being lost. If we think about it in the right way, sometimes we can even have a net positive outcome. There are examples of that out there, believe it or not. But we're doing this site by site by site. So these are 3 examples of places where we've worked with companies, with government. Let's see, the upper left is actually in your backyard. It's in Utah, it's the Uinta Basin, with the project we had with Questar at the time. Now they're QEP Resources, and I guess Questar sells you your electrons. They're the electricity portion of or energy portion, like natural gas and other things, and QEP Resources is the more extractive side. That's not important for the story. The upper right-hand side is Mongolia, and that is the Olgu Togoi mine. It's a copper and gold mine that Rio Tinto is involved with as a partnership with the Mongolian government. And the bottom one is the Great Western Woodlands in Australia. So we think about that mitigation hierarchy, applying it from the perspective, and that's how it's applied now, from the perspective of all those individual developments, but we put it in the context of the background of all the other development leases that are being considered. And you can quickly see that piecemeal, place-based, one-off process is not going to work. It's also not going to work for renewable energy development because you're going to have some of the same problems, same issues around land use conflict. And that's what it causes. So these are just some headlines from a couple of places where I've worked. You end up with 2 different camps. One that's pro-development says, oh, the environmental community is trying to stop job growth. And you have the environmental community saying, well, development's going to destroy the environment and we're going to lose everything that we care about. So it's this piecemeal, one-off approach that I think sets us in that antagonistic process. So what needs to change? Well, the simple way that I refer to it is we need to go big and we need to go early. So we need to go to a scale that's relevant to the development patterns that are going to happen, and we need to do it really early. So we need to do it before people have made huge investments in exploration or trying to understand their development patterns. So really quick, I'm going to walk through some examples, and if I can keep my nerd brain from going to too much of the details, I just want to keep them sort of high level. So there's a bunch of them. So if you see me going too nerdy, someone just go, give me that the signal, move it along. But what needs to happen and what are the sort of the big pictures? We have to have a conservation vision. So what is it that we care about in the place that we're trying to manage or conserve and look at a development outcome? We need to project that development as best we can. We need to understand not just next week, but the next 10 years, the next 20 years, where that development pattern is likely to go. We need to understand how those things collide together. Are there tools that we can use? What mitigation steps are important so we can develop those kinds of big picture blueprints? So a key part of that is projecting future development. And this is something we've spent a bunch of time in my team and a lot of people that we collaborate with on to be able to project future patterns of resource development. One thing I'm going to give a really quick qualifier. We're doing this not to cite oil and gas wells or wind turbines, but to really understand in general where those development trajectories are likely to go. So they're important, they're useful for conservation and development planning, but not, the oil and gas industry isn't going, oh, wow, the Nature Conservancy just helped us figure out where to site our oil and gas wells. That's not what we're trying to do. This is a picture in the Central Appalachians, and this is shale gas development, which is the new normal there. This area is incredibly important. It's a biodiversity hotspot, but it's also the backyard of our largest mega population in the U.S., from New York City down to Washington, D.C. It's heavily forested, about 70% of it is forested, and about 20 million people rely on those headwaters for their drinking water, and that's surface drinking water. So it's really important. This also shows the number of people that are in different watersheds by the sort of size of the groups of people standing together, and the darker area in the middle there is the high pressurization area that's going to be ground zero for a lot of the development. And the USGS has done a lot of modeling to understand how the resource is distributed, how many wells it'll take to exploit that resource to full potential. So we used a lot of that information. We also knew where about 8,000, 10,000 wells currently existed, and so we used those to build a predictive model. In the species world, when I was mostly a biologist, we would go out and we would collect locations of where some critter might be, and we'd characterize that. It uses this type of habitat, this elevation, this vegetation structure, and then we could build a statistical model that says, here's where it's likely to occur based on the fact of where we found it. Doing the same thing with oil and gas wells. We also knew where planned development was, so we can estimate the effectiveness on a model, and these are pretty good. Again, we're not trying to cite the exact location of the wells, but just get a general idea of where development's going to go. We can then use this predictive model along with estimates of footprint. So we had colleagues who went in and digitized all these existing wells, how many well pads, roads, and pipelines, and this sort of physical space that takes. Same thing for wind development. I'm mostly picking on oil and gas here. We can do the same thing for wind. And then we can put those on the ground, and we can say, what does that look like? And so what you're looking at is it's clicking through a series of developments that first off is where we currently are. The least impact is where we are now. And the end impact is a full build-out scenario where we're putting fewer wells on pad. So, and the colors represent really a shift in impervious cover. So impervious cover is just cement, packed roads. It's the stuff that water runs off really easily on. And so we decided to focus on impervious cover model primarily because that's what people cared about in this space, was the water quality issues. And so one of the striking things was just, one, you can look at small hucks, small watersheds, and highlight where there's likely to be issues around water use and development. And those local municipalities have to plan for that because they're going to be the ones that are responsible for making sure the water is still clean for drinking water use. But you can also see some simple things like, well, not surprising, if you put more wells on one well pad, you dramatically reduce the footprint. So it's this kind of work, this kind of forward visioning that has to become part of our normal development planning process, and it's not right now. So now I'm going to go through, and this is where you really have to help me not to get into my nerd brain. I'm going to go through three quick examples. First one's going to be looking at place that's near and dear to my heart, Mongolia. Looking at how we're achieving conservation goals in the face of development. Then I'm going to turn things around. I'm going to say, how do we achieve development goals in the face of conservation? Then I'm going to show you a really interesting modeling tool that we've built that lets you do both of them at the same time. And again, please throw something at me if I start getting too nerdy. Mongolia is an absolutely spectacular place. It is one of the countries with the lowest population density on the planet. About 40% of the people are still nomadic herders, so really closely tied with nature and depend on nature. The country has also made some really super aggressive commitments to conservation. ACHI targets, as part of the Conservation and Partners, has set the goals at about 17%. They're trying to reach a 30% protection goal. So our project was really to help them figure out how to do that in a way that also lets them develop. This is a country that has very few paved roads, at least when I started to go, they had very few paved roads, and not even basic infrastructure. So they're clearly going to develop, and they clearly know they have these amazing conservation values, and so that was the goal. How do we do the conservation and the development at the same time? So this is the creation of that conservation vision that I mentioned. What are the critters that we care about? And I apologize for the Mongolian Cyrillic. It actually adds a little more, maybe a little more excitement or flavor. But so there's a bunch of different species that we care about, and they have certain distribution patterns. There's unique ecosystems. There's a bunch of places that are really important for evolutionary processes. Within this mix, just because I couldn't fit it all in one slide, we were also looking at social and cultural sites, historic sites, and then areas that are important for those nomadic herders, so that they can hay when there's a really harsh winter. So all that's built into this planning process, and we identify a set of a portfolio of sites that will help us meet that vision if we protect it and we manage it with those goals in mind. Then we can ask, okay, what does the development footprint look like? So this is a variety of different leases that are proposed. It's mining, it's energy, it's other infrastructure pieces. And so then look at the overlap with that conservation portfolio. And so there's a lot of overlap with that conservation portfolio. And so we could either, at that point, we could either say, well, get in our camps and say, yep, you can't do this development, or go ahead and they want to do the development. That's going to completely ruin the economy of Mongolia. But through the process, we knew these conflicts were going to arise, and we had developed a way to assess the value. So in some of those places, we could redesign our conservation portfolio, and those are the ones in orange. It's orangish for me. I think hopefully it's orangish for you. So those are places where we had flexibility on where and how we could meet our conservation goal. So we could pull those out of the portfolio and try to meet them somewhere else. And the blue areas represent places where we couldn't. And the values we were trying to conserve, given their distribution, their rarity, were only found in those places. It provides a transparent structure and mechanism to help see and resolve some of those conflicts. And so we redesigned the portfolio. The new portfolio sites are in green, and the ones that are blue are, there's no change. And you can say the conflict remains. I'll mention what happens to those. If we look at where this led to over the course of 8+ years, first started in the Eastern Steppe, went through this process, conservation vision, looked at conflict, and the Mongolian government has used this to designate about 64,000 square kilometers of new protected areas. That's the Gobi example is the one I sort of focused on. It's also been used to designate about 34,000 square kilometers of new protected areas. The government then said, wow, we love this. This is working really well. And they funded us to do this for the rest of Mongolia. And again, it's been used to designate about 48,000 square kilometers of new protected areas. It's about 43% of our conservation portfolio, 9% of Mongolia. When you add it all up, it's about 150,000 square kilometers of new protected areas, about the area the size of the state of New York. Now those are protected. A lot of them now need to be managed. So one of the other parts of this process was where there are impacts, There are offset funds that are generated that are now steered to some of those protected areas so they can be managed effectively with the goals that they're intended to achieve. A lot of those conflict areas, about 50% of them, ones that were on that map that still remained, about 50% of those leases have been retired. And my colleagues in Mongolia are actively working to try to get those other 50% of the leases retired for development. So that's great. Mongolia is also a very different place to work, low population density. So let's jump to the US. Wind farm in the Midwest, this is in Kansas. And I want to talk a little bit about how we're sort of turning the tables to use our conservation planning tools to help achieve development goals. So the Department of Energy has set some ambitious plans for wind energy. Started out with the 20% by 2020, and now I think it's 30% or 35% by 2030 or 2035. But in both of those cases, they've created a spatial blueprint for where that development should go. And so that's the green map. So each state has a gigawatt target in wind that it could achieve. It would, if it hit, it would be part of the bigger, broader goal. And so what we did was ask, okay, well, how can we do that in a way that's going to reduce impacts, that won't create conflicts with conservation, so we can help support development? So the first map underneath it is a breakout of where the wind potential is, so where the wind blows, and you can calculate then how many megawatts that you can generate based on a wind turbine that's in a different wind power class. And the next map down is a map of disturbance within the US. So these are places that have lower conservation value, and it's pretty granular and pixelated. So it might look like Utah has none, but you'd have to zoom in. There's some in Utah. And then we could ask, the last map is, how do you then translate the wind goals, the wind potential, and those converted areas into whether the state can meet their goals or not? So all the states that are in blue could meet their DOE wind energy goals on converted lands without having to convert new land to meet that target. And the red states could not. Some of them by very small numbers, but that's the result of that analysis. Not a political blue state, red state. But that's great, but now we need to also start stepping these things down. This is just a different way to depict that same outcome. So the little red line at the bottom is where the DOE target goal is for the country. The red ones below can't meet it. The blue ones above can, and it also, the size of that bubble tells you about how much wind they have. We argue in the paper that you can also start to do some swapping for energy. Like California, for example, can't meet their wind energy goals on converted lands, but they're already pulling electrons from states around them, from solar and wind. So there's a lot of ways to plan for this. But we need to start to step these down into blueprints. This is Kansas from another analysis that we did that really takes that more granular look at the country level and says, okay, here's a blueprint for how it can work within Kansas. And colleagues for the Nature Conservancy within Kansas are using this with utilities to help establish power purchase agreements that will facilitate this transition to wind development on lands that are low conservation conflict. So last story. So this is how we're going to achieve conservation goals together, novel modeling framework. Working in Brazil in the Cerrado, collaboration that we did with a couple different companies. One of them was Dow Chemical, who was looking at generating biofuels from sugarcane, so an ethanol cracker plant, go from sugar to create a biofuel, part because of the requirements in Brazil, but also for some of their feedstocks for some of their industry. It's in the place where a lot of this is happening is in Cerrado, which is a global biodiversity hotspot. About 50% of it's already been cleared, and it's very, very little of it's protected, mostly all private land. And so it's shifting from Cerrado to cattle ranching to sugarcane, or in some cases from Cerrado to sugarcane, or in some cases to other soy or other crops. So this was just a case study to really look at the forest code in Brazil, which I'll talk a little bit more about in 1 second, and how to sort of use that regulatory driver to create that balance between development and conservation. Brazilian forest code, fantastic regulatory mechanism. It requires that private landowners maintain a portion of their land in forest cover, and also that you have these PPAs, permanent preservation areas, that are along water bodies on steep slopes. The problem with it is it's not being fully implemented, but it's a really powerful approach. And where you are in Brazil dictates also how much of that forest cover you have to maintain. So it's a lot more in the Amazon than it is in Cerrado. Cerrado, it's about 25%. So normally we would go in and we would look at our environmental models and we'd try to bring that forward. But it's really clear that we need to take a different approach to sort of bring different kinds of tools forward. And so this is a process that Christina Kennedy led with a bunch of partners at Natural Capital Project, the University of Minnesota, that started first with economic models. So really built what's the economic profitability of agriculture when you look at it spatially across the landscape. Combine that with biodiversity models that say, okay, if you configure habitat in different ways, here's how many species you can maintain. And then also with ecosystem service models like INVEST from Natural Capital Project, which also are a function of, in this case, water quality is a function of how and where vegetation is placed between where there are disturbances and where the water bodies are. So we stole a little bit of a tool from the economics folks, and these are efficiency frontiers. So what you're looking at is, and this got a little bit messed up, but looking at is the number of species on this graph and a metric of water quality on this graph, and across the bottom is just agricultural profits. So as you increase agricultural profits, you see a change or a shift in how species or water quality responds. We also ran a different set of different optimizations that look at different ways to emphasize what you're trying to conserve. So if you focus on biodiversity solely or water solely. So the big take home from this first is that that's where the current environment is, the current landscape is, that's where we're performing. Without changing agricultural profits, we can have a dramatic impact on the number of species just by reconfiguring the landscape. So we can add another 94 species. And we can also increase water quality dramatically, about 50% increase in water quality. You may notice, though, that these optimizations, this one here is optimizing biodiversity, this one here is optimizing water quality. It's a little bit of a trade-off, and we can see that when we optimize just for biodiversity, we get about a 30% reduction in water quality, and we get equivalent sort of reduction in biodiversity when we optimize just for water quality, about 58 fewer species. But if we know that, and that's often going to be the case, we know that up front, we can plan for it, and we can include it in our design, and we can actually have the outcomes that we want to see. So when we optimize for both, we can actually maintain about 94% of the species and a high level of the water quality. The important take home from this, one is an absolutely fantastic modeling approach that NatCap folks are turning into a tool called Roots. But these kinds of things, these win-wins or these compromise outcomes, they're not going to happen by accident. You're not going to fall into this. We have to actually plan for them. We have to bring these kinds of tools into the mix. And we're not. That's the reality. So last thing I'll leave you with is my ABCs for resolving these land use conflicts, which are only going to get more intensive as the population grows and we need more energy and more food and more water. Has to be ahead of where the impacts are. It's got to be at a bigger scale. We have to think about the conservation outcomes, and we have to think about the development objectives that we're trying to achieve. If you're interested, we have a myriad of peer-reviewed publications, reports on this work. I'll throw the website up. The only recommendation I'd say is don't read them before operating any heavy machinery. And then if you're interested in some more deeper dive into the energy stories, this gives a smattering of some of the projects we have in the Energy Sprawl book and some really fascinating outcomes and approaches. What still eludes me to this day is why these best practice examples are not more common practice, especially since they make sense for everyone, for the conservation community, for the regulatory environment, and for the business community. And so we're trying to crack that nut right now, but we have not figured it out. And so those case studies are found in the book, and you can dive more into our website on nature.org. That's all I have. Thank you so much. I gave a presentation at CU Denver to a bunch of lawyers, which I understand there's a lot of lawyers here, and they were just crucifying me. And my colleague who's from UT Austin, who was doing a sabbatical there, invited me. I was like, during the middle, I was like, hey, this is supposed to be fun and easy, come on. He said, so let loose with your hard questions.
I'm not going to give you a ton of hard questions, but two things. One thing, I really think the cheapest kilowatt hours and the most efficient kilowatt hours are the ones we don't produce. And energy efficiency, I know that's
totally
not the focus of your presentation, but I do think that the talking about where to build the next solar panel without talking about conservation is a pretty tough thing. Your opening slide with the Tehachapi wind in the background, solar in the foreground. I'm a developer, so I actually have a solar farm nearby. There is a way to direct development to previously disturbed lands. And the reason Tehachapi occurred, and the reason my company built, 8,000 or 8,000 acres of panels a little bit further south, is because the California Energy Commission rate-based an interconnection upgrade in Tehachapi and there. And so it was kind of a if you build it, they will come thing. But that if you're trying to direct solar and wind development, that is a way to do it, to say, hey, this looks like a previously impacted area, it's a good solar area, it's a good wind area. If you, as Nature Conservancy, can help, we've got a former PUC commissioner here, help the states direct like where those upgrades should occur, then private IPPs like myself can say, hey, there's a cheaper interconnection, there's an upgrade here, everybody's decided this is a good place to do it, and then that could actually kind of help industry coalesce in a location that has less impact. And I guess that's not a question, but maybe more of a topic that could be helpful to get to your end goal.
Yep. Well, first about the energy efficiency piece, I can't agree more. And the first paper we published on energy sprawl, a big part of that was, I think in the title of the paper is Energy Sprawl or Energy Efficiency. And so we looked at the land savings footprint of using energy more efficiently, using less energy. So wholeheartedly agree with that. But I think the reality is that we're still going to develop, we're still going to build, and so we are thinking about that. And our main goal is to try to help renewable energy move forward as fast as possible. And the reason that I think we're highlighting the footprint issues is not because I think that is the primary concern. I think what's going to happen is that if we're not thinking about the footprint and those land use conflicts, it's going to slow investment in a sector that's already fairly risky in terms of investment around. Energy tends to be a fairly messy or risky way to move things forward in terms of investments. So can't agree more. The other part of it, which wasn't a question, and I agree, is that I think we need to figure out ways, and it's not at a, I think it is more at a state by state level, and we're doing that now in some states. So our California program has California's move to 100, and so they're pre-thinking, okay, where and how can California do that? How can they work with both industry and state government partners to really help identify those go areas that will ultimately reduce the risk and investment. We played a big role in the solar PEIS, which helped identify solar go areas. and you're seeing some positives with that, with a reduction in permitting time. So the kinds of things you're mentioning, I mean, I think we just have to do a lot more of those, and want to see, to make your job easier, to be able to get more solar down and in the ground.
I think ultimately we're sitting on a transmission infrastructure that's 20 plus years old, and getting upgrades in the areas where we want to see development will cause the result, I think, that you're trying to get to.
Yep.
And it's rate basing those things, getting bills passed to allow them to be rate based, so that the cost of upgrading a 20, 30-year-old system is not sitting on the back of the developer. And that will help focus the development in areas where you feel there's less impact.
Yep. Yeah.
Just a comment on how it could get done if you're trying to do it.
That's great.
Can I just ask you if the presentation you gave is available on the Nature Conservancy website or somewhere?
Yeah, I don't know that it's on this particular set of PowerPoint slides is online, but if you send me an email, give me my card, happy to send it to you. If anyone else wants it, or if you guys want to post it somewhere, go for it.
Even without the comments, it's useful to show to some people at the DAQ and other government agencies.
Great. Yeah, most of the work that's presented is either already in peer review publications, with the exception of one or two things that's in review right now. Hopefully reviewer number 3 won't torpedo.
No one likes reviewer number 3.
Nobody likes
we all say reviewer number 2. Thank you very much. I thought it was a fascinating presentation. I'm very glad to be here. I really appreciated the variety in the case studies that you presented, and it was nice to start with Mongolia and how supportive the government was with your work. And I was wondering if you could kind of speak to the elephant in the room with Brazil and the election of Bolsonaro. And I know this isn't about politics, but I can't help but view that a little pessimistically.
Yeah. Well, I can draw the relationship to the U.S. as well. I'll just keep the sort of politics as much out of it as I possibly can. We worked a ton with the Department of Interior, and I mentioned, you heard that Sally Jewell's going to be here. Sally's an amazing person, and I think really helped the Department of Interior, a bunch of presidential decrees that set up the regulatory environment to do what we're talking about. In fact, they called this kind of stuff out as as clear as possible. And then a lot, all of that rolled back. One of the things that we're working on in Brazil is looking at how wind and solar can replace the need for hydropower. One of our big conservation priorities in Brazil, not surprising, is the Amazon. A lot of the freshwater biodiversity there. Biggest threat to freshwater biodiversity is hydropower development. And so our push has been to look at alternative development strategies. And we just got some funding with partners at Cornell University who think about grid modeling, who I have a hard time talking to sometimes because we don't seem to speak the same language. But we figured out a way to get together. But so to look at, keeping in mind the grid and load demands, how you can integrate intermittent wind and solar to replace some of the hydropower. And the story hasn't been told yet because we haven't done all the analysis. And the upshot of that was that the Brazilian government, just a couple years earlier, is requiring, as part of some of these hydropower projects, that they also consider alternative forms of energy. Awesome, right? Because now there is no low impact hydropower. That is the take home. So we've been looking at ways to site hydropower projects that reduce the impact, but they still have just an absolutely massive impact. So this was a great opportunity to now say, okay, we have this, let's look at a set of alternative energy solutions that are both renewable, that can avoid that. With the new administration, it's a TBD. So I don't have the answer to that, but I don't have a super positive, and things like the Brazilian Forest Code that have already been semi-laxly enforced you know, who knows what will happen with those. So sad. It was a sad day.
So a lot of the energy development that occurs here, especially in the western United States, you alluded to this earlier, is on federal land. And there's an environmental impact process that goes in, happens prior to, presumably, at one level or another, the energy development. From your experience, do you have any thoughts of how that environmental impact analysis might be improved, either at planning levels or project levels beyond go big? Do you have some thoughts more specific than that?
Yep. You know, strategic environmental impact assessments are something the EIA community does infrequently, usually doesn't do very well, in my opinion. But those are the kinds of, again, forward-thinking, big-picture views that are supposed to be done in the BLM field office. There's a name for the reports that they do. It's eluding my memory at the moment. But they're supposed to look at a vision for 10 or 15 and 20 years. They're not, so that's an avenue, and it's one that TNC pursues actively in places where we think those development and conservation conflicts are going to happen, to really try to get those done in ways that are going to make those exchanges happen. Sorry if there's anyone from the BLM here, but those are not, right now, are not done with the current technology that we have to make them provide a better, stringent assessment of the trade-offs. But those are definitely ways, routes into the process and the mix.
Well, with that, let me thank everyone for joining us today. Dr. Kiesecker will be available outside to sign his book if you're interested. And I should also note that the presentation, there was a question about that, is available on the Stegner Center website if you're interested in following up with, to sort of view it again. So thanks again, and we'll see you next semester.